So friends, in this video, we'll talk about one of the very important function in Excel, forecast function. So usually when we do forecasting of any financial data related to any company or any business, so if this forecast is based on the historical trend, we normally apply historical mean, median or mode functions to see what the trend in the past, and we try to replicate the same trend in the future. Now in today's video, we'll learn how we can use this forecast function in Excel more effectively to do this forecasting in a scientific manner. And especially if your business is a seasonal business, then how we can factor this seasonality also in the forecasted numbers. Because usually we see when there is a seasonality, when there is an up and down in the financial data of the company, our median and average thing does not factor this, because it just take the average effect of all the numbers, right? Ups and down. Now in this video, we'll understand how the seasonality can be factored in the forecast, and we can do this same exercise in more quicker and a faster manner and in more scientific manner, right? So guys, to understand this, I have taken sales data of Maruti, and this is the data for the sales volume, right? It's not a sales value. This is the volume of vehicles sold by Maruti on a quarterly basis. And why I picked up this company? Because automobile business is a seasonal business. We understand that, right? And this seasonality is clearly evident from this quarter-over-quarter growth, which I have calculated on this data. So first of all, I show you the historical period. I've taken this data starting from March 22. And last updated quarter is September 25. So I'm recording this video in November 25, and the last updated quarter is September 25, right? Now you can see, guys, if you look at the growth trend here, I can see that in March 22, we had a sales volume of 488,000 units, which in June 22, it has declined to 467,000 units. There is almost 4% decline, right? In the next quarter, again, there was a up, right, in the sales volume of 11%. Then in the next quarter, December 22, there is a dip of 10%. And this almost same trend I can see in the next year also. Plus, minus, right? Again, plus, minus, plus and plus, I can see December 24. This last year, December 24, there was a growth. Then again next year, minus, plus, and the trend is still going on. Now, guys, I can clearly see there is a seasonality in this data, right? Now, in case I do this projection manually, so what I'll do, I'll simply calculate an average growth, right? This is what we usually do, whether it's a yearly data or if it's a quarterly data. So I can take a growth of average growth of quarterly numbers. So if I take an average growth like this, average, okay, and if I just select the entire range of historical growth, quarter-over-quarter growth, it is coming 1.3%. So my average growth as per last almost we can see almost 15 quarters, we have average growth of 1.3%. And if I apply this growth on my estimated data, so my next quarter sales volume is expected to be 1 plus 1.3%, 557,000 units, right? And then because I have taken this growth based on the historical data of 15 quarters, I'll assume this 1.3% growth consistent for all the future quarters, right? Now, if I drag down this calculation, I can clearly see that there is no seasonality in my estimation. I have simply done this estimation using a linear growth of 1.3%, which is consistent throughout. It means in this kind of estimation, seasonality impact is completely out, right? I can also show this, how this data is not correct. I can show this by creating a line chart based on this quarterly data, which includes your actual data and estimated data also. So if I go to insert and create a line chart, right? I can create this line chart here, okay? Now guys, you can see here, I should not pick this growth percentage. So let me just recreate this chart, okay? I can just create chart based on the, quarter ending date and your sales volume. So insert line chart and Yeah, this one, sorry. Now guys, you can clearly see that up till here, September 25, I can see there is a clear trend, there is a clear seasonality in this data, right? There is a seasonality involved in this data. After this, my sales volume is increasing consistently. There is no seasonality. If I add a trend line here to understand this trend better, add trend line, right? So you can see guys, this is my trend line and my projection is just close to the trend line. But historically, this data was scattered. It was not, all the points were not falling on the trend line. They were around trend line, but there was up and down. There was, the actual trend was up and down, zigzag. So it means this sort of estimation is not factoring seasonality impact. Now, the other way of doing this forecasting in the Excel is, if I just delete this, okay? If I just delete this, and if I use forecasting function of Excel like this, forecast.linear, okay? Then first it is asking me to link X. X is what? My quarter ending date, which I want to estimate first, comma, Y, known Ys. Ys is what? Your sales volume, this one. This data you have to link the historical sales volume. Function F4, because you need to freeze this range, because when you will drag this down, you don't want that your trend should shift, right? Your historical data should shift, comma, x-axis. So you have to select the entire historical quarter ending date. Function F4, enter. And now if you drag this down, this time again the result is almost same guys. You can see in the line chart, till here there was a seasonality, but after this line is matching to your trend line. Can you see this trend line, the dotted one? This trend line is just a trend line only, right? Though the estimation is better than the average one what I applied previously when I just calculated an average growth of the quarter sales. But here, I don't see any seasonality, right? So how do we factor this seasonality in the projection? We'll understand this. So for this guys, I've used the same data. So let's move to the next spreadsheet. In the same, I have same historical data here, but rather than applying a forecast function here, I'll be using this data tab. Go to the data, and can you see this forecast sheet? So just click on the forecast sheet, and the moment you click on it, you will see guys, there are two colors. The line chart is in the two color. The yellow one, the blue one, this one is the actual data line, and the orange one is indicating the estimated line. And guys, you can clearly see there is this line is zigzag, which is factoring trend, which is almost same as my historical numbers are growing, right? Changing. If you want to see what sort of seasonality is factored, you can click on options and you can see, okay, first of all, this forecasted period is ending up to March 29, starting from September 29, starting from September 25. So you can see guys, my start date is what? September 25, because my last actual numbers are ending on September 25. And this forecasting period is ending on September 26. So if I want to extend this projection period, maybe for say up to September 30, maybe for next 5 years. Okay, so I can change this date. So my now projection is ending till 1st September 30. Seasonality, can you see the seasonality? It is detecting seasonality automatically based on the past trend. Otherwise, you can set manually also, but then you have to see, provided the input given, the seasonality impact is monthly, quarterly, or what. Then guys, I'll just group this option function and create. The moment you create this, let me shift this line chart a bit. So let me just resize it, and you can see guys, in my chart area, there is a seasonality, right? You can see there is a seasonality. This orange line, this zigzag line is with reference to the past trend, right? And also you can see one line is upper trend and one line is downtrend, which is nothing but the best case and worst case scenario. So you can see in the estimated data, we have a base case scenario here where it has estimated my all the quarterly volume data. Upper confidence bound is basically the best case scenario if the actual numbers estimated numbers are better than average trend. And here this is what the this is the lower confidence bound and this is the upper confidence bound. So lower is actual numbers are, you can see that my lower case bound sales volume is 5,10,000 for my first estimated quarter, where the base case was 5,54,000 units. So 5,10,000 versus 5,54,000. I can see there is a drop in the estimated numbers, and here this is the best case scenario where estimated numbers are more than base case scenario, right? And likewise they have estimated numbers for next 5 years, right, on a quarterly basis. So here I can see there is a clear cut trend capturing, seasonality capturing in my financials, in my estimated numbers. These estimated numbers gives me better picture of future estimated earnings or sales volume of Maruti. So guys, you can see this is how we can use this function more effectively in the Excel, where rather than just putting average data, average trend, or using a forecasted function in cell, right, function, rather we can use this forecast sheet function in Excel, right? So I hope you enjoyed this video and you will be use this function more effectively in your DC evaluation exercise or projection exercise. In the next video guys, I'll take you through Monte Carlo simulation, how we can use Monte Carlo function in the estimation, where again this Monte Carlo tried to capture uncertainty about the future, but here we apply probability to different scenarios. So till then, stay connected, stay tuned. Good luck.